doing today. This is our last lesson in chapter 4. It's our last lesson of the whole trimester.
Woohoo!
Woohoo! Next week on Monday, we're going to review chapter 4 because we'll need a little review after that long break. On Tuesday, we'll do our one-pager, and next week, Wednesday, will be our test. In this class, the chapter 4 test will be your last test. We're not going to have like a trimester 1 test. When you take your chapter 4 test, that's our last test of the trimester. Okay? Do you have any questions about next week or the end of the tri?
How many points?
About 30. It'll be about the same as all of our other tests. So just chapter 4 stuff. Good question. Any other questions about next week? Okay, then grab out your notes. You can title it 4-6 part 2, Equilateral Triangles. We won't go now. Strength factors. You turn these in.
No, you're supposed to study those.
And then when you come back,
Alright, so 4-6 part 2, equilateral triangles. We have 2 theorems, and then we have 2 examples where we're going to find a missing measurement. And then we do have 1 flow proof that's kind of complex today, but I'm really confident that like a solid 65% of kids in period 4 understood it. So we can do this. I believe in us. Alright, so we're going to start with equilateral. Equiangular Theorem. Also known as the E theorem. Because when we do this in a proof, we are not going to write equilateral, equiangular. That's a lot. Yeah, it's okay. Alright, what the equilateral, equiangular theorem tells us that if it's an equilateral triangle, what does equilateral mean again?
Equal all sides.
Yep, all the sides are equal. Then it is also equiangular. And what does equiangular tell us? All the angles are equal, yep. So these happen at the same time. If we know that all the sides are equal, we can assume all the angles are equal. Or vice versa, we can swap that around. If we know all the angles are equal, then we can say all the sides are equal. So these always happen at the same time. Okay? We have one more theorem, and this is our equilateral angle theorem. So we just said that if it's an equilateral, that means it's equiangular. All the angles are the same. So if we know all the angles are the same, we also know that all the angles have to add up to what? 180. So what number plus itself 3 times? So number plus the number plus the number. So 3 of those numbers add up to 180. So what plus what is 180? Have to all be the same number. Or you can think 3 times what is 180? 60. So all angles have to be 60 degrees. In an equilateral, we know for a fact all angles are 60 degrees. Alright, so we're going to do 3 examples. one example is going to take up like a half page, so it's going to be similar to yesterday with that flow proof. It's probably going to do 2 examples on the front and then your last example on the back. Alright, so to start off with, we're going to draw an equilateral triangle to the best of your ability. Beautiful. Beautiful. We know it's equilateral, which means all the sides are the same. And this angle right here is 2x minus 24 degrees. And our goal is to find x. So, is this 2x minus 24, is that representing an angle or is that representing a side? An angle. And what do we know about all angles they all equal 60. It's 60 degrees, 60 degrees, and this is 60 degrees. So to solve for a missing value, we generally want to write an equation, usually. So if I look at that angle, this 2x minus 24, what is that angle really going to equal? 60. Because all angles equal 60. Leo, focus. Play Tetris during work time. And then we're going to solve that. Some of you are really great at solving these. Some of us took a little hiatus from school last year when we were in COVID and we struggled with this because we were sleeping a lot during COVID, which is okay. It was tough. Okay. So if you're not sure how to solve this, I'm going to talk through it. If you know how to solve it, go for it and just do it on your own. Okay? The way I like to think about this is best friends. Who is the best friend of the x? The 2. So I'm going to keep the best friends together. And what are we going to get rid of first? The non-best friend, the 24. Because my goal in the end is to get x equals. So how would I undo a minus? What is the opposite of minus? Good. If we do it to one side, we do it to other side. So then we get 2x equals now we're going to be a mean person and break up the best friends. How are we going to undo that 2? What? How did you know to divide? Because what? We're trying to get the x by itself? Okay. But why can't I just subtract 2? Good. When they're right next to each other, that means multiply. So if you need to throw in a little time sign there, you can do that. So we're going to divide. You guys are just way too smart. And if we do one side, we have to do the other side. So x equals 42. Was that the answer to the question?
What was our question? Did we find out? Yeah.
All right, number 2. We're going to draw another triangle. This time this triangle is going to be equiangular. So I know all these angles are congruent. It's not a great picture, but I marked it, so it's true. This is 5x minus 14. And this is 3x minus 6. So we see that all the angles are congruent. what else does that tell us? If all the angles are congruent, all the sides are the same. Did it matter that the angles are 60 degrees? And this one, no, because we're talking about the sides. So we really know these sides are the same. So I can write the equation 3x minus 6 equals, that's one side. What's the other side? 5x minus 14. We know all the sides are the same, so we know that they are equal. Again, our direction should have been to find x. Sorry, forgot to write that. Alright, so this time, what's a little different about this equation compared to the last one? It's different. You're right. It's a completely different problem. Yeah, we have an x on the other side of variable. It's not just a number. So when you have variables on both sides, what do we want to do with them? We want to get them on one side or eliminate one of them. Do you guys want to eliminate the 3x or eliminate the 5x? Yeah, I always like mine over here. So if I eliminate a positive 5x, how could I completely get rid of it? Minus. And if I do that on one side, and on the other side, where am I going to put that? Underneath the 3 or the 6? 3. So what is 3 minus 5? Negative 2x. That 6 is still there. Minus 6 equals 14? Negative 14. So it was a minus 14. Alright, at that point, if you feel good solving that, go ahead and solve it. Or just stare off into the distance. Alicia's real good at that.
You made that equation off from?
Yeah, because we knew that since the angles were all the same, that means all the sides are the same. So all the angles are equal, which means all the sides are equal. Yep, that's the theorem. So we're going to start by adding 6 on both sides. When we have a positive and a negative, what do we really do? We really do the problem. You're right. We're going to subtract. What's 14 minus 6? 8. And then do I have more positives or more negatives? Negatives. Alright, and then to get x completely by itself, how am I going to get rid of that negative 2? Divide. So for some of you, this might be coming back really quick. Maybe it was just you needed a refresher. Maybe you have no clue what's going on and you're going to ask for help during the work time, and that's okay. But we end up with x equals 4. Alright, we have one flow proof to do. My flow proofs, I just take up a lot of space because I like the flowing. I like to do my arrows everywhere. So I'm going to go to my new page. Mine actually took up like 2/3 of a page when I did it. What? Yeah, we have one more. But the one more is going to take up for me it takes up 2/3 of a page.
Pretty big.
You might do yours smaller, but my flowing gets real flowing. Alright, number 3. We're going to practice that flow proof. We're given this triangle. It says W, X, and Y. This is 60 degrees here. And this side is congruent to this side. And what we need to do is we need to prove that the triangle WXY, so that triangle is an equilateral triangle. So that's our goal, is to prove that the triangle is equilateral.
an equilateral.
All sides the same.
All three sides the same. Do we know that yet? No.
Rather than proving all three sides are the same, what else could we do?
Angles.
All the angles are the same. What do we know more about currently with triangles, sides or angles?
Yeah.
We know more about the angles. That's something that we learned yesterday with the angles. Okay. What do we know? What was given to us? What information? Okay, measure of angle W is 60 degrees. So that's given. What else do we know? The sides are congruent. WX is congruent to WY. Okay, I like using my highlighter instead of using boxes. My boxes get really sloppy when I do flow proofs. So if you want to draw a box around your statements, you can. Otherwise, you can use a highlighter. Remember, it's just the statements get boxes, not the reasons. Alright, so if we know that two sides are congruent, what else do we know? If two sides are congruent, what kind of triangle is that if two sides are congruent? Isosceles. So yesterday with isosceles triangles, what did we find out? If two sides are congruent, the angles are congruent. Yeah. What angles are going to end up being congruent here? So angle X is going to equal angle Y. Does anyone remember what theorem is that says if the sides are equal, then the angles are equal? That was from today. We're looking from yesterday with the isosceles. Yeah. The isosceles triangle theorem. What do we know about all the angles in a triangle? So if I do the measure of angle W plus the measure of angle Y plus the measure of angle X, what is that all going to equal? 180. That didn't come from anything else. That's just a theorem we know. We're adding the angles in a triangle. So what is that theorem called when we add angles in a triangle? A triangle angle sum. You got it. Because sum is another word for add. So instead of measure of angle W, what do we know angle W is? 60. So let's say 60 plus, I can do measure of angle Y, but what do I know measure of angle Y really is? X. So these are really the same. So I could write it as like 2 times the measure of angle X. Because they're really the same. We could write it as measure of angle X plus measure of angle X. So we got that from the 60 degrees here. Where did I get that I could do the X and Y? I could just call them both X. Yeah, it's what we said. We said X and Y are the same. What do we call that in an equation when we switch something out? Substitution. Crushing this. Okay, so we're just going to kind of do a pause here. We're going to not really do the flow proof for a second because this is just a lot of work if we were going to do it with a flow proof. If I solve this equation, 60 plus 2x equals 180. What am I going to undo first?
The 60.
How will we undo the 60?
Minus 60.
Subtract 60, and if we do it to one side,
You want to get? Sure. Okay, so then we get 2x equals 120. And then how do we undo multiplying by 2? Divide. So divide by 2. So the measure of angle x equals what? 60 degrees, yep. So that's actually our next statement, is just this part. We could have done that in like 4 statements, but we're just going to kind of skip over that. Here's our flow. We went to this, which gives us this. And that's like our subtraction property and our division property of equality. I'm going to just write property of equalities here. POE. Alright, so what do I know now? If x is 60 degrees, is there anything else I can say? What about y? Yeah, y is the same. So if x is 60, then y is 60. What do we call that when we switch something out? Substitution. So instead of saying angle x, or it could be substitution, or it could be if y is x and x is 60, then y is 60. So it could be substitution, or it could be transitive. You guys remember transitive? Whoa, flashback. Okay, we are so close. Now we know what about all the angles. They all equal 60. So I'm going to put those two into an arrow, and I'm actually going to draw an arrow all the way from our given down. So there's a lot of thoughts going on here. If all the angles are equal, what kind of triangle do we have? Equiangular first. Because they're all the same. And that's really just our definition of an equiangular triangle. So I'm just going to write definition here. If we were writing this as a formal proof that was going to get published in a textbook, we would write definition of equiangular triangle. But this is just our notes. So we're just going to write the definition. And then we know because it's equiangular, what does that tell us? It's equilateral. And what tells us that if something is equiangular, then it's equilateral? The equiangular, equilateral, or equilateral, equiangular theorem. So we're going to call that the E theorem. It's the one we just wrote down on the other page. If it's equiangular, that means it's equilateral. Whoa! We did a flow proof. It makes sense to like 60% of you? Some of you? 20%.
You had me at the beginning and you lost it.
Yeah, me too. I agree. I'm glad I had you at the beginning, though. It's a start. All right, today you have the rest of the time to work on your practice. Your practice is pretty much like numbers 1 and 2. At the end of your practice, there are going to be some problems like just kidding. At the end, there's going to be some problems that are true and false. So I think it's the last 3 problems are true and false. The first couple problems, you're really just finding x, or you're using the idea of equilateral. Okay?